Hey everyone, welcome to the 290th episode of the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And if we sound a little bit different today, it's because both of us are feeling a little draggy here in the middle of the pandemic. Blah. But
more coffee.
We're sucking down more coffee, and we have a really good show. We actually have lots of news. Apple introduced the HomePod Mini, and we're going to be talking about that. Plus, there's a secret thread connection in there. It's actually not secret, but we'll talk about what that means. And I have been working on my smart home speaker strategy, and I finally figured it all out. So I'm going to share a little bit of that with y'all in case it helps. Google has a new thermostat for the masses. We've got AR goggles for dogs. And yes, they are called exactly what you think they are. In less uplifting news, we've got stats about e-waste, and we're going to be talking about sustainability. Even Apple mentioned it. We've got smart benches in Auckland. Alphabet has a new moonshot project. And Cisco is introducing cloud-managed sensors for the IoT. Plus, we're welcoming a new sponsor, Silicon Labs, so you'll hear from them. And we had a lot of cancellations this week on my guests. And at the last minute, I finally gave up and said, you know what? We're going to rerun something. It's not a guest that many of you have heard unless you attended our machine learning event back in July. So I have Dan Jeffens, who is a general manager of data science at Shell, and he's actually going to be talking about machine learning at the edge. This was recorded back in July, but everybody is now talking about machine learning at the edge, and not just like the smart edge, but like the thin, stupid edge. So I think you're going to really enjoy this, especially if you haven't heard it. All right. So let's get this podcast started with a message from another one of our sponsors. This week's sponsor is Very. This week's sponsor is Very, and it's Best of the Smart Home Awards. So, are you out there and ready to win validation, recognition, and visibility for your smart home product? Apply now for the 2021 Best of the Smart Home Awards at bestofthesmarthome.com to get your product in the hands of judges like myself and Rob Tiffany, who is VP of IoT Strategy at Ericsson. You can go to bestofthesmarthome.com and you should apply today. I'm excited about that, Kevin. I think I might get some fun things to play with. Yay!
I hope so.
I don't know if I'll be able to talk about them until the end. Oh, sigh. Wow. Okay, we record on Wednesdays. Y'all probably know that because we say that probably at least once a month. But on Tuesday, Apple did an announcement, and everyone's talking about the new 5G phone, which does come in some very pretty colors, and the Mini is right-sized for sure for people like me. But we were so jazzed about the HomePod Mini, which means, one, Apple has not forgotten the smart home, which I didn't think they had because they keep updating Home and HomeKit. But they came in with this tiny little HomePod that is $99 and really, it's like 3.5 inches tall. It's a tiny little thing. And it supposedly sounds good and allows you to control your HomeKit devices via voice. So it's their smart speaker. Unfortunately, it still has Siri inside.
That's not a terrible thing, depending what you're going to use it for. I mean, if you're going to ask for information, general information, maybe there are better digital assistants. But if you're an iOS user, which you probably would be if you were going to buy this, they've actually added some smarts to Siri for information sharing. And it can now support up to 6 different people's voices and the information for those people.
Yes. And unfortunately, my quick sum up of this was at $99, this device has cemented the trifecta. So Google, Amazon, and Apple now all have a digital assistant and a smart speaker for $99.
While the event was going on, you and I were having a little online chat, and I said, I'll bet you the price is like $149, $179, but it probably should be $99. I mean, Apple does compete in its markets with higher premium pricing. However, it's so far out in the smart speaker market because of that $300 HomePod from 2.5 years ago. It just can't compete unless it gets to the sub $100 price, I think. And they did.
I agree. And they did, yes. So $99. The other thing is they basically copied a lot of the features from Google Assistant in terms of things like, hey, it will link to your iOS apps like your calendar. Who's using iOS calendars? I don't know. But if you are, you can ask, I was going to say Madam A, but you would ask Madam S, what's on your calendar for today? Or what's my first class? And it would tell you. And then they also stole the Amazon Echo 4th generation's form factor.
It's rounded like a bowling ball, but then it's kind of cut straight across the top. It looks exactly like some citronella candles I've purchased in the past for the deck, to be quite honest.
There you go. Yes. Well, it's better than a fondue pot. Remember the Samsung thing?
Yes. And don't forget, iOS users, they do use the calendar and those native apps because Apple typically doesn't let you change the default apps. That's only a recent change. So keep in mind, that's why they make it work with those apps.
Again, I look at this and I'm like, why be so closed? But, and here comes the fun part. We talked about, so actually we should talk about a couple of features before we get to the fun part. So what I thought was really killer was you can use the intercom feature like you can with every other smart speaker on the market. But with this one, you can actually hijack your kids' AirPods or your spouse's, I suppose, and have the message go over their AirPods and say, hey, dinner's ready. I think my spouse might get frustrated with me if he's like on a work call, but
It also goes to their car if they're using CarPlay.
Yeah. Again, Apple's creating this connective tissue between all of their products, and that's actually really compelling, I'll be honest. And then the other thing is it has the ultra-wideband chip inside, and that allows you to do a couple things. You want to talk about that, Kevin?
Yeah, sure. And Apple actually has put the same chip, their U1 chip, in the previous year's iPhones. So that was kind of setting the stage for what they'll be able to do now with the HomePod Mini and the ultra-wideband. So if you bring your iPhone in close proximity to a HomePod Mini, you could hand off music. Perhaps you're listening to music at home on the speaker, but you're heading out the door to go wherever. You just hold your iPhone next to the speaker and you can have the music continue playing on your phone so you can keep listening outside, which I think is pretty neat. And then you can take it to your car and so on. Additionally, if you put the iPhone next to the speaker, you'll get personalized recommendations for songs, which I think is a little hokey. You can kind of do that without proximity, but whatever. I don't think it does anything else yet. I think they're talking about some more features coming.
Yes, but if you combine their focus on proximity and their focus on being able to share information from all of their devices for people in a household, things get exciting. But there are things that are already exciting or closer to being exciting, and that is inside this HomePod, it supports Thread. And y'all may be familiar with Thread. Thread has had many iterations, but it is a wireless protocol. It's 802.15.4, and that's also the same protocol that runs over Zigbee, or that Zigbee runs over, I should say. Anyway, Thread is going to be one of the supported protocols for Project Connected Home over IP, and that is the mega special smart home standards group with Apple, Amazon, Google, Samsung, and like everybody else, like 140 something odd other companies in this space. And what Apple is saying in the specs, they're saying this only works with HomeKit compatible Thread devices, which means that there are going to be HomeKit compatible Thread devices, which means Apple is seeding the market here with devices that I assume will one day be Project Chip compatible. So that gives me warm fuzzies. That plus the 140 some odd other companies gives me warm fuzzies that this is actually happening. And by this, I mean a legit standard for the smart home.
Right.
Now, the fact that it only works with HomeKit, it doesn't say like, I don't know if that's going to be forever. If it isn't forever, then I feel like, ooh, then it gets a little like, how's that going to work? Maybe this device only works with HomeKit compatible ones, but others will have the Thread protocol and they will work with other things, which means we'll probably see a bifurcation around smart speakers or ecosystems, even with chip, which would make me sad. Well, it kind of depends on how that works out.
That would defeat some of the purpose, I think, of chip, but we'll see.
Yeah, well, we'll just have to wait and see. So the idea here, we haven't really talked a lot about that. We didn't talk about that in our post because in all honesty, we didn't notice it until a little bit later.
One word, Thread, in the specs. Because nobody mentioned it. They didn't mention it in the event, and I didn't see the word Thread, so yeah.
We're going to burn Kevin at the stake tomorrow. No, we're not.
That's fine. That's fine.
So that's that. So then the question becomes, Kevin, you actually have our original HomePod that we purchased for $349.
That's right.
Would you buy the HomePod Mini?
Well, If I was an iOS user, sure. And I have typically been an iPhone user. Unfortunately, for this particular speaker, I switched over to a Surface Duo Android phone about a month ago. But if I was an iOS user, sure.
Okay. And I bet you'll be an iOS user again. Y'all, we know from the show, like the things we get in the show, the HomeKit lovers out there, y'all are strong. Y'all are mini and strong, and y'all love HomeKit. So I do think there's a huge market for this. I think we'll see some cool features, and I'll probably pick one up just so I can play around with it, even though I am an Android user. My husband's on iOS, so maybe he'll get a lot of fun out of this. I can intercom him. Ha ha ha. Okay. This brings us to smart speakers and what would we buy? So earlier on this week, I was trying to figure out my smart speaker strategy heading into Prime Day. Because of what Kevin and I do, we like to have all of the speakers because we have to test things. So because I moved to a new house and I have all the first gen Echo stuff, I know, like my Echo is 5+ years old and I had the original Echo Show running around that I replaced it with a Google display recently. So what did I need? I needed great sound in my open area living room. So I was hoping for the Echo Studio. I got the Echo Studio. I didn't like it. I felt like it was super loud, did a great job with bass, and its high end, its treble, and its mid-range were really just muddy. I didn't like it. Not a lot of clarity in there. And that didn't work with the type of music I was listening to, nor the experience. So I needed something that filled up a room, but I didn't need it to be like, the party's here, y'all. I don't know what accent that was. So that's a bust. You know, in my displays and my single versions of Echoes and Nests, they didn't work. They're just too lame. So my plan is now to get 2 Nest audio speakers. Also, the Echo Studio is huge, very large. So it's to get 2 Echo audio speakers for $99 and place them strategically around the room, which is a little difficult because I don't have a lot of table space in that room, but I'll figure it out. I do wish I could mount them on the wall.
I'm sure somebody makes a
little shelf.
Yeah, because we've seen them. People have made them for the Echo Dots and the Nest Minis. So you can put them in your ceiling, put them in your wall. I'm sure there's something out there.
And I will say, Google designed their speaker, like both Apple in the Echo Studio and the new Amazon are designed to give 360 sound. But most people don't need 360 sound because they stick it against a wall. And so I was noticing that in the Echo Studio. I was like, I know you're adapting to the room, but I still feel like there's a lot of bounce back happening.
Yeah, and even with the HomePod event, they were showing like the speaker in the middle of a room. This tiny little speaker in the middle of the room. Who does that?
No one. I mean, maybe if it's on your coffee table, but there's no outlets at the middle of the room. Anyway.
Exactly.
So I'm doing 2 Nest Audios in the main living area. I am going to get an Echo Dot with clock for the bedroom. So I have I'm going to say 30-year-old alarm clock in there just because I like the display. I like to be able to look at it in the middle of the night. And then I'm going to get the robot Echo Show. It was like the Echo Show 10 that follows you around. I'm going to put that in the kitchen so it will be near the Google devices. But this way we have a choice. We can ask Madame A or Google to help us out with our inquiries. And
sure.
Yeah, I think that's where it goes.
So I have a question because we often get this question. People are like, which smart speaker should I buy? And we tell people before you buy any smart home devices of any kind, choose your digital assistant / ecosystem / platform. And you're mixing and matching. I assume you're doing this because of the audio.
I'm doing it because it's our job. And I'm also doing it because I don't mind doubling up on, if you have 2 assistants, you have basically 2 assistants to manage. And there's no benefit to doing that really. So if you want to have everybody in the house to be able to say either, hey, G, or Madam A, do this, you have to set up the same routines, you have to set up the lights, you have to set, it's, and they're making that much easier. And I was kind of hopeful that Chip might help with that, but I don't know if it will. So that's the smart speaker strategy in a nutshell for now. I also need a speaker for my study, and I'll probably do just a straight up Amazon. No, I'll move my Google display because I like having my frames of my family in there. So I'm moving a display in here. So it'll be exciting and fun. Okay, let's talk about Google's new thermostat. On Monday, Google said that they were going to have a new Nest thermostat. This is not going to be a Nest Learning thermostat, so it's not as smart as the $250 Nest, but this Nest thermostat is going to be $129.
Yeah, that's actually a very competitive price compared to most of the thermostats out there. And no more sliding ring, the old Nests.
Well, that's expensive. That's a pricey thing.
No.
I will say also this week, Wyze did come out for pre-order with their $50 smart thermostat. So I wanted to write about like a tale of two thermostats is really where I was going to go with this and talk about at the high end, we had Google with the Nest when it purchased Nest for $3.2 billion, y'all, back in 2014. Oddly enough, the thermostat became the hero product of the smart home. And then the smart speaker came out later that year. And so what I feel like we're doing right now is in bringing the hero product to the mainstream, companies like Wyze and Google with this new device, this new cheaper thermostat, is really kind of a disappointment. And I say that because I thought everything was going to be smart and like work together, right? That was the kind of promise behind the original Nest. But people were like, oh, it's expensive. People were fighting with it. We didn't have standards, so it didn't interoperate easily with things. And even Google like pulled back on the strategy there. They not just by introducing this thermostat, but also things like saying, oh, the way we did our APIs, they're not right for the way this world is evolving. So I feel like now we're in this world of lesser featured connected devices, smarter digital assistants. And so what we're seeing is we're probably going to have a bunch of connected devices that we're going to buy based on price and ecosystem.
I agree with everything you said. And I see, in particular, in the thermostat market and in the smart speaker market, the approach was kind of backwards. It seemed like premium smart products came out first, and not everybody wants to spend $300 on a thermostat, when it first came out, or $3 something on a HomePod when it first came out. So instead of coming out with the smartest but highest price products first to develop this industry, they probably should have come up with the cheaper ones first and added smarts and boosted the price.
I agree. I think you're right. And I think they were doing that to show what could be possible, because otherwise it's kind of like, who cares about a smart thermostat? The other thing is, I really don't think the mainstream cares about smart thermostats. I'm really interested to see how many people rush out and buy these things, even at a low price point, because I don't think they're realizing what they're about to get into, which is suddenly you have another device in your house that you have to care about and manage. And it's not hard, but it is something.
It's the device that I think most people interact with the least, though, because if it is truly smart, it generally does everything for you in a sense once you set it up. I don't go to my Ecobee anything. It knows I'm home. It knows what temperature I like, and that's it.
Well, and with this, what you'll have is you'll have the ability to schedule the motion sensor. The motion sensing is done by Soli, not by a PIR. And the addition of Soli isn't for like gesture-based controls. It's just so you get a wider field of view for the motion sensing, which makes sense. And it'll be like, oh, let's turn off those energy-saving features and make sure they're comfortable.
Yeah, it doesn't have much more smarts than that.
And of course, you can talk to things and tell it, hey, make it warmer, make it colder.
Right. And see, that gets to the point that you were making. It seems like less smart and cheaper devices might be the endpoints in the home, but you'll control them, say, through a digital assistant, or they will just be smartly controlled through a digital assistant or a hub.
Yes. And, I guess I'm okay with that.
Yeah.
All right. Let's talk about Doggles.
Doggles. Yes. Not to be confused with Douglers, which are dogs at Google. That is a real thing. People who bring their dogs to Google, those are called Douglers. But Doggles, yes. This is a prototype being developed by Command Site, and it's being overseen by the Army Research Lab in the U.S. And basically, these are AR goggles for dogs. I kid you not. So basically, they are connected so that the dog's handler can be remotely looking at what the dog sees and sending commands to the dog to execute. So that way, they don't have to be right next to them and so on and so forth. I mean, obviously, there are military implications all over this. It's a military design, but I still think it's pretty neat.
I think it's so weird. I mean, for a couple of reasons. One, dogs' eyesight is not nearly as cool as their nose, right? So I guess I see the benefit of us augmenting a dog, like from the sense that we are making its eyesight better by using our eyesight, which is much better. I just don't see the point, but sure.
Basically, you're turning the dog into a drone.
Right. I'm like, but why would you use a dog when you could use a drone?
Well, drones do make noise and they're very expensive. And
A trained military dog is very expensive.
I'm sure it is, but I suspect an actual drone is very much more expensive.
I just don't like it because we're putting dogs in danger, and dogs don't like
I know.
things on their face. Like, if you put a hat on a dog, they're going to be real mad at you. I can't imagine Doggles. Anyway, it's a cute story.
I can't get Norm to wear his mask during this pandemic for that very reason.
Oh, Norm. All right. Other news. This is not great. I should tie this back to Apple, which I can. Apple.
And Google,
Yeah.
actually, because they talked about this in the Nest Thermostat news. But go ahead.
Oh, yeah, they did. Okay, so Apple at its thing said, hey, that phone we ship, we're not going to send you any more power cords or the little cheap headphones that we've been sending out with the phone for sustainability reasons. And, mostly we're all like, yeah, you just want to sell us more stuff. But they are right in the fact that, yes, Apple does have a lot of cords lying around and nobody uses those headphones. Actually, I use those headphones for just keep a set in the car in case someone calls. But yes, I get it.
I have a dozen iPhone charging bricks in my closet right now. I kid you not.
So I see that point, but I also see the point of people who are like, but now I have to, plus when you sell your Apple device, you send the cords back, don't you? Anyway.
No, you don't have to. Nope.
Okay.
Nope.
So there you go. They're doing that for sustainability purposes. And Google, what's Google doing?
Yeah, so with its new Nest Thermostat, Google says, hey, we're focusing on recycled materials as well. Plastic parts contain 49% recycled post-consumer plastic on the Nest Thermostat, and their trim kit, which they include, is made from 75% recycled post-consumer plastic. They've been trying to do that quite a bit with their smart speakers as well.
So, yes, there has been very much a focus on recycled plastics in these things. But I am more interested in the e-waste thing. And I wrote last week in the newsletter about how we should be starting a conversation about this. So I'm glad to see that this is actually happening. And I should also make a plug because it's something we're actually going to be talking about at a smart home event I'm doing at the end of this month on October 27th. We've got Bjorn Block from IKEA. He's going to be talking about recycling electronics and how to think about kind of sustainability with all of these connected devices we're buying, using for a few years, and then throwing out. And along those lines, the volume of e-waste has increased by 21% globally in the last 5 years. That means it is doubling every 16 years. And this is from a report from the United Nations Global E-Waste Monitor for 2020. India was one of the biggest contributors towards e-waste, but it's just such a challenging project because what happens is you've got these devices and they have the plastics, they have glass. The new iPhone will have a ceramic layer. You've got
rare earth metals.
Yes, in the chips, you've got rare earth metals. And these things, they're not designed to come apart very easily. So there's a lot that needs to happen here.
I'll be honest, and just circling back to your smart speaker strategy, this is why I have not purchased any smart speakers in a while, and I have no intention of upgrading what I have because I don't know what to do with all the ones that I have. And I don't want to contribute to the e-waste.
Yeah, it is. I'm like, what do I do with these old Amazon Echoes? I mean, I'll try to find them. There are recycling centers.
Find them homes, yeah.
But yeah, I don't have a lot of faith in that, I guess. So, but it's been 6 years, and my oldest one is actually, sometimes I'll have it play music and it stops in the middle of the song for no reason. So I'm like, it's probably time. All right, let's talk about smart benches.
Which we've talked about before.
We have.
Yes, in Auckland, New Zealand, one of the telcos down there lit up their 5G network recently, probably this week, because everybody's doing that with the new iPhones. Spark is partnering with the Auckland Transport, and they're showing some of their IoT stuff. And we've talked about these smart benches before, but yes, they are connecting these solar-powered smart benches that also have device charging capability, but they're also now using 5G for connected lighting, which is kind of interesting to me, and smart bins, smart refuse bins that can deliver real-time alerts about their capacity, as well as parking sensors on the network. So they're going hog wild over there with 5G and connected devices. So
nice. And street furniture is a good place to kind of try that out. So also, Google has, or Alphabet, Google's parent company, has a new Project X. This one is called Mineral, and it is aimed at taking soil data, satellite data, crop data and predicting how well a plant will grow. And this is designed for food crops. Precision agriculture is nothing new. John Deere has been doing this sort of thing, and they've got computer vision on their tractors and combines that help sort seeds, that help understand where to spray for weeds. So I'm a little unclear at what Google's going to bring to this. I'm assuming it's the data analysis and maybe some models around these things. Farming data is tough because every single crop, you have to deal with something for every single crop, right? This is not it's kind of like identifying individuals and then figuring out what will make each of the billion of us grow and be a great person, right?
Yeah, I think you're right. I think it's on the data side. And I'm just going to say, if anybody has seen Tron, these mineral things look exactly like those flying security things, and it's super scary looking. That's all I'm going to say.
Yeah, they're big arches that you roll around the field. It's kind of crazy. Also, Cisco has launched 3 new sensors, the MT10, MT12, and MT20, to give data on indoor temperature, humidity, water leaks, people in a room, that sort of thing. And what they're selling is the sensor themselves plus all of the means to connect it, so a bridge for those sensors to get data to the cloud, and then the management platform. They're tying in their Meraki acquisition. Meraki was their enterprise Wi-Fi acquisition forever ago. They're doing this to understand, I'm assuming this will be for the data center and kind of those environments. So, because it's very important, manage temperatures and things like that in there. But, the key thing to know here is that Cisco has jumped on the bandwagon that everyone else has finally realized is real, which is IoT is happening, it's real, but companies do not want to put it together themselves. They just want to buy a package and deploy it easily. And this does that.
Right.
Okay. And now it is time for the Internet of Things podcast hotline voicemail. This section is brought to you by Schlage. The best home automation adds convenience, not hassle. And with its built-in Wi-Fi, the Schlage Encode Smart Wi-Fi Deadbolt shows you just how easy secure can be. You can learn more at schlage.com. And what we are doing is, if you give us a call, you will be entered to win a smart speaker of your choice. So we're going to do Google or Amazon. Basically, you get a $99 smart speaker, or you'll be entered to win one. And to do this, all you need to do is call us at 512-623-7424, and you will be entered to win. This week's voicemail is from Derek, but Derek had some connection issues on the phone, so we're not going to include his call simply because it was hard to understand. So there was just a lot of cutting in and out. But Derek wants to know the purpose of hubs. And he wants to know if he should look for devices with hubs or without hubs. And this is a great question because Kevin and I are very split. I am pro hub, 100%.
Well, and it's not that I'm anti-hub.
Oh,
in fact,
Kevin.
no, I don't like all the extra bridges and gateways and all these other things. But that gets to the heart of what a hub or one of these devices can do. So, Derek, essentially, one of the key features of a hub is to allow devices to connect to your Wi-Fi network. So maybe it's a Z-Wave device or a Zigbee device or a Bluetooth device. It kind of integrates all those radios to get the devices on the same network. That is one aspect of them.
In addition to that, a hub can also be a good place to put the smarts for a device, because then you can replace a hub instead of the device that you paid an electrician to screw into your wall, for example.
Right. I would agree.
So where are you anti-hub, Kevin?
It's not that I'm anti-hub. I just don't want all these boxes around my house. I'm fine with one centralized smart hub, such as the SmartThing, such as the Wink, such as Habitat. That I'm fine with, because that allows me to locally, in many cases, have my automations and routines. It is the central nervous system or the brain of my smart home. That I'm fine with. But when you have to have all these, and it's getting less and less these days, but this is why I stay away from Philips Hue for a while. I didn't want to have yet another little bridge or box to get those lights onto my network.
Yes, but in the Philips Hue case, that keeps the lights working even as changes, like you just replace the hub. But yes, as someone who has are you ready for this? I've got a Philips Hue hub. I've got an IKEA Trod-free hub. I have got a Lutron hub. That's just my lighting hubs. I have some old lock hubs for a Bluetooth-based lock. Do we call them locks? They're really, or do we call them hubs? They're kind of bridges. If I wanted to, my AirThings air quality monitor comes with a hub so the Bluetooth could talk to the Wi-Fi. But I don't have that because that just...
Yeah, I tend to stay away from those types of devices that have all these, I'll call them proprietary bridges or gateways. Some of them you have to have it. I mean, I get it. Like the Wise, everything uses a different radio or protocol, and the hub ties them all together and gets them onto your network. But again, you can do far more automations and things with a hub than you can with a hubless home. Like I don't consider the Google Home products a hub. I don't consider most of the Echo devices a hub.
But some of them have Zigbee.
One Amazon
So
does.
one Amazon, yeah. Does none of the Google products have any sort of Zigbee or Thread?
No.
Okay.
Not that they're using it.
Right. Okay.
You know.
Yeah. I know some of them have the radios, but
So without a hub or without being a hub, that's when you have to say, oh, I want to automate something. Then I have to go to a third-party service to get those automations going, like IFT or something to that effect. So the long story short, for Derek, if you want to have total local control over things and you don't want all these boxes and bridges and such, then maybe a hub is the way to go. It seems like the market is moving away from that, however.
and with Project Connected Home over IP, should it happen, man, I feel like I feel like somebody with like extreme faith here. It's like the Church of Chip. It will come and it will save the smart home. But with something like that, we should see a reduced reliance on hubs because we can put that intelligence and control and provisioning into a single device that will work across multiple sets of products. That's the hope. Well, if you would like us to answer your questions, give us a call at 512-623-7424, and you will be entered to win the smart speaker of your choice. And that concludes the news portion of the show. Let's get ready for a message for our sponsor, and stay tuned for my conversation from this July with Dan Jeffens, the general manager at data science at Shell. It's gonna be awesome. Hey everyone, we are taking a quick break from the Internet of Things podcast for a message from our sponsor. This week's sponsor is Silicon Labs, and I have Jake Alamet, who is Vice President of Home and Consumer at Silicon Labs, here to talk to us. Hi Jake, how are you today?
Very well. How you doing, Stacy?
Excellent. So let's get this started by telling us a little bit about what Silicon Labs does.
Thanks, Stacy. A little bit about Silicon Labs. We're the #1 provider of silicon software and solutions for a smarter, more connected world. Our award-winning technologies are shaping the future of the Internet of Things and can be found in many of the different devices that you have within your own home.
Excellent. So, speaking of the home, what do you see as the next big opportunity in the smart home?
So the opportunity in smart home, it's very robust today and it continues to grow. The biggest opportunity is where we drive true scale, where smart connected devices are as commonplace as the electricity in our homes. When we solve these problems, we'll not only keep consumers safer and save them money, but we'll make it super easy for them to set it up, to work seamlessly with other devices no matter where they came from, and to ensure that they're secured from threats. When we do this, it will drive growth of smart home immensely. And at Silicon Labs, we're the #1 wireless provider to the smart home. We support all the major wireless protocols and are actively participating in the largest smart home ecosystems. We're truly a one-stop shop for wireless and smart home IoT. Just recently, we had a smart home developer conference last month, specifically to bring all these ecosystem players and device makers together in a place where we could discuss what are the next steps to take and drive that vision of the smart home out into the future. We're super excited about the engagement that we had at the Works With conference, and we look very much forward to continuing that effort in next year's event, coming together to really collaborate on how we realize the vision of scale in the smart home.
I participated in the Works With event and I thought it was awesome. What was your takeaway from it?
You know, for us, Stacy, what was really useful is just the engagement and interest level and conversations that we had with folks from all across the ecosystem and in the device maker community, working together to really capitalize on the opportunity to make smart home truly ubiquitous.
I'm sure we'd all love that. So, where can our listeners go to find out more about Silicon Labs?
Folks can learn a lot more from our website at silabs.com.
Let's welcome Dan Jeffens, who is the General Manager of Data Science at Shell. And we're going to be talking about how Shell's using machine learning and computing at the edge and all sorts of fun things. So hello, Dan. How are you?
I'm very well. Thank you very much for having me.
Oh, we're so excited. And thanks for doing it late at night. I feel like you should have a cocktail.
Absolutely.
You're like, I didn't know that this is that kind of conference, Stacey. Oh, my. All right. Well, let's just start off. Why don't you just tell us what you guys are doing at Shell with machine learning at the edge, and we'll take it from there.
Yeah, for sure. So let me first of all start off with machine learning and AI, because I think that's an important place to start. So within Shell, we've got a pretty holistic program focused on scaling up AI right across our organization. We call that Shell.ai, and it's really a change program that's designed to embed AI in every part of our business and organization. Because I think what's important to recognize about this whole journey, be that machine learning in the cloud or at the edge, and we'll talk about that later on for sure, is that actually it's all about business change. This is about changing the way that we do things in terms of the processes that we run every day. So Shell.ai is a pretty big deal. We've got about 3,000 people engaged in the change program right now. We've got about 1,200 people or so engaged in developing AI solutions in some way, shape, or form. And of course, we do a lot of work in the cloud, and increasingly we're starting to do some work at the edge, which is really exciting, and we see a lot of opportunities there. So I guess maybe start there and see where you want to go with that. But it's a big thing for us.
Yeah, no, that's a lot of people, and it's a good point of business transformation. I feel like a lot of the time in the tech world, we're all like, "This is cool, let's do it," and it is cool. And we should do it, but we also need a good rationalization. So let's talk about the use cases first at the edge. So What are some of the things you're trying to do? Because Shell is huge, has many use cases.
Yeah, so I think it's probably worth talking a little bit about sort of what we see the edge being good for. I mean, you alluded to it earlier on, and I thought you did quite a good job in terms of talking about some of those cognitive senses, the simulation of human perception. And I think that's one of the key areas that we see real application for this. We tend to focus on the edge really for two reasons. Firstly, as has already been said, where it's a real-time use case. In other words, we need sub-second response. And so the edge is obviously the best place for that. The second scenario is where you've got really large data sets, which you don't want to ship over the network into the cloud. And so those are sort of the two areas where we're exploring this as an approach. And I guess there's probably a third where bandwidth is a real problem. So we already talked about situations, and one of your previous guests did my job for me, talking about some of the challenges that we have in embedding sensors in real-time operations in extreme operating environments within the oil and gas industry. And that's, of course, something we have to think about a fair amount. So those are really sort of the why are we using the edge. And so what we see is that there's a number of use cases that are emerging where that's highly relevant. You talked about machine vision. Inspection is key. We're already deploying a significant number of drones and robots, as well as subsea robots that are designed to inspect our facilities, our pipelines, remotely, controlled by humans at the moment for good reasons, for safety reasons, but effectively bringing back video feeds which can then be interrogated. Now, a lot of that can be done in the cloud, but in some of the filtering of those cases, particularly in remote locations, we see edge-based use cases for that, and we're experimenting with deploying models onto robots and onto drones on low-factor compute in order to do some of that processing.
And
so that's one example.
I just want to clarify. So in this case, they're going over and they would be looking for problems, right? So they have
Exactly.
a model that they're running that
Exactly.
against. Okay.
Yeah, exactly. So typically it's computer vision type scenarios. So to give you an idea, and again, one of your colleagues helpfully alluded to the case already, looking at things like corrosion on pipes, that's a good case. It takes people a long time to inspect some of these vast facilities and large amounts of piping. And so if you can have a drone or a robot that's doing that, 24/7, that's a huge opportunity in terms of just improving the whole inspection process, both in terms of effectiveness and efficiency. I will say one of the challenges is data, and no doubt we'll come back to that. But that's a great use case. As I said, it's kind of the same thing. We've got a similar example, subsea, where we're doing this on top of pipelines. And then we've got the same example where we're trying to do it in the air from drones.
Okay. And I think you're even using it at your gas stations, correct?
Yeah, that's an interesting one. So, I mean, again, what I will say is a lot of the things I'm going to talk about are early. They're things that we've worked with. We've developed them as initial small-scale pilots. We call them minimum viable products. And so I don't want to give the impression that we're there and we've got it all sort of nailed down, but at the same time we're making some very exciting progress. We've talked openly before about some of the stuff we've done in retail, looking at particularly safety applications. There's actually a lot of challenges from a safety perspective in terms of situations where you may have people who come and drive off, or situations in which you have smoking activities at gas stations, and we've experimented with those cases. I will say that one we found particularly difficult to scale, and maybe that's something that we'll come back to, because I think that's something that in general we struggle with in Shell.
Yes, and that is such a beautiful segue, Dan. I love it.
Thank you.
So you have talked about how there's a lot of promise here, but your controversial opinion is that it's not there yet. And can you talk about why this is more hype than reality today? And by this, I mean machine learning at the edge.
Yeah, absolutely. I mean, I think I do want to sort of start by saying machine learning in the cloud is very much now. We are doing a huge amount of machine learning in the cloud, and I just want to give you some ideas of the size and scale of that. It's important to say the oil and gas industry has been doing sensor technology for a long time and has been aggregating that into central environments for a long time. In fact, we kind of led the world in developing that technology, I would argue. And so, we've got over 1 trillion rows of aggregated data in the cloud, which we use to develop thousands of machine learning models, which monitor our equipment every day. So in the cloud, this is very real. It's very big. It's very now. And we've talked very publicly about some of the things we've done in that space. I think partly because we've got very good connectivity anyway, and partly because this is quite difficult. We've struggled to get yet the scale that we want on the edge. And maybe just to unpack some of the issues behind that. I think the first thing is the operational challenge of running things at the edge. If you're running a device and you're running it on a rig or in a manufacturing facility, for us, the refinery, or for example, if you're running it in a wind farm offshore, or if you're running it on a solar farm, or if you're running it at an electric charging station, all of those things tend to be remote, and also are quite tricky to maintain for different reasons. So there's a whole logistical problem about the edge, which is what happens if the edge device breaks? How do you replace it? How do you manage it? How do you upgrade it? And some of that requires people still to go to the edge and figure it out. And that, I think, that failover and those sorts of things are maturing, but I would argue from what we've experienced are often not yet fully mature. And we've certainly learned a lot about some of the challenges of doing that. I think the second factor is simply cost, because there's often benefits to doing things in real time, but often you're willing to compromise, even in low bandwidth situations, if you are spending a large amount to have an edge device do the computation. So if you're really talking about high cost edge, it doesn't work at scale, because you end up coming back to the point, well, will I accept the latency on the use case in order to move the data back to the cloud? And often the answer is that that's more cost effective. So I think that's another scenario where that cost point for low cost edge with the right computational capabilities, I think that's emerging, and I would argue perhaps not yet fully there. I think the final thing is simply model management at the edge. I mean, for those that are in the machine learning space and have worked in AI for some time, you'll probably know that model management is a challenge anyway. So just being able to manage thousands of models is a real logistical headache, and it's something that we've been trying to figure out. If you add to that thousands of models running in thousands of edge devices where latency may be a problem, you actually have a lot of risk. And I heard one of your previous guests talking about firefighting scenarios, and I'd love to understand how they do it, because I mean that's an even more extreme environment. But for us, thinking about how do you manage those sorts of logistics and how do you maintain that at scale are some of the things that we're still working through. And this is why at the moment, a lot of what we're doing is still these minimum viable products and Pathfinder projects, rather than things that I would say are truly enterprise scale yet.
Okay, and that makes sense. So let's dig into those, because you just said a lot of things.
Sorry.
No, that was good. That was a wonderful overview. So let's talk about I'll call it the people problem, which is dealing with like changing batteries. So talk to me about what you guys have experienced. I feel like you've got this trifecta of really remote operations. So you might have to like literally fly someone out over the North Sea. Yeah. You've got highly educated, well, I don't know how highly educated, but you have deeply technical knowledge, probably doing some of this. Absolutely. And then you have, now I've forgotten the other one. We'll come back to it. But so talk to me about the challenge that you faced, or maybe use a project that you've tried to implement where this became an issue.
Yeah, sure. I mean, maybe I'll give a couple of examples. I mean, I think the first and perhaps best example of this is, I did a bunch of work looking at how do you maintain and manage smart charging solutions for electric vehicles. Now, that might sound like a very simple thing to do, but what we found was in that scenario, some of the work had to be run in the cloud. A lot of it could be done there, but some things had to happen on the edge. So you actually had to be able to deploy physical hardware into the charger to control the interface with the car. And if you look at that example, what we struggled with that business model was the fact that effectively each installation of chargers and the combination then of the compute that goes with that, and then the comms box that manages that, and then the integration of that with the clouds, and then the management of that charger in the cloud as a discrete device, that was very, very complex. Now, it's not that it wasn't doable. We successfully deployed this end-to-end solution as it was to 4 or 5 sites. The issue that we had, though, was that when you start trying to do that and you start trying to do the economics of scaling that up in conjunction with the business model, when you look at the logistics of managing that, maintaining that, the people you have to have on the ground to do that in the location, the fact they have to drive around checking these things, you really start to realize that the math just doesn't add up in terms of the economics yet. And so we ended up moving to more of a cloud-based solution for a lot of these things. But it's just an example of where, a proof of concept that we've worked through, you can see how some of these challenges become really real. And when you're talking about some of these things, you're often talking at a few $100s per device. So there's not a lot of room for high cost compute in that.
No, and that's kind of gets to your second point about cost and the trade-off between, why am I doing this at the edge? Am I doing it because of latency? Is it worth $5 extra per compute cycle?
Exactly.
And we'll talk about that. Actually, the next panel after this is going to be about business models for the outer edge, because they don't really exist yet.
Yeah.
But let's get to the data modeling and keeping that. I don't know if it's coherent or keeping it synchronized or how to start thinking about that. But how are you guys dealing with that challenge?
You mean in terms of bringing all the data together?
Yes, and then figuring out how and where to send it, and making sure everything's working when you have. Oh, and we should also talk about the scale that you're talking about, because I don't think people realize it.
Yeah.
How many sensors, when we talk about Shell's Edge, what are we talking about?
Yeah, I mean, I don't, to be honest, I think I don't even know. What I can say is that we've got literally hundreds of thousands of edge devices that are all communicating to our cloud. And by edge devices, I'm using that in the loosest possible term. It's everything from base sensors through to IoT devices, to cameras, to mobile devices and the like. As I said, we've currently got about 1.1 trillion data points aggregated in the cloud that we use for machine learning training, so it's a huge problem is bringing all that data together. And I think what I will say as well, and it goes to a point that one of your earlier guests was making, what we're trying to do is also learn about how do you build these secure, reliable, robust pipelines from the edge to the cloud, with then the underlying data structures in data lake stores, with delta management, because that's also an important point. And how do you manage all of that? And then how do you make sure you can take that and train machine learning models on top of it and manage those models and have end users manage those models? So that's basically the problem space that I spend most of my time thinking about. And how on earth do we set up a technology stack to achieve that?
Can you just give up on some of that and just say, we're going to dump 90% of the edge data because it's not interesting? Because that's what I feel happens. People are like, oh, we're going to lose this and just do a model that says, I care only about these things and everything else just goes away. Or is that inclusive of all of that?
In fact, that's what we do, right? I think I think the big thing is, this is not all the data. We call it a curated data lake with good reason. We heavily curate the data feeds that we take in, because if you take in too much, it just becomes unmanageable, and also not useful, because data scientists can't get what they need in order to train their models. So we curate this quite heavily, and yet still, this is the sort of volumes that we're talking about, even pared down to things, because we are only bringing the data in that we want to use to train machine learning models. We're not bringing in all data. And we, to give you an idea as well, this is growing at about 10 billion rows a week at the moment. So we're expecting that that's going to grow pretty exponentially over time as well.
I can't imagine how you sleep at night. But they're growing. The data lake is growing while I sleep. So talk to me about hardware. And this might speak to the cost issue too. But there's a lot of emphasis right now on machine learning at the edge in special processors. Yeah. And I'm really curious, is that helpful? And maybe we should make the distinction between inference versus training, because we're not talking about training. Yeah. And how, are those helpful, or do those just bring up costs? I mean, what is your thought process on that?
I think so. Let me answer that in two ways. I am quite excited, and we've obviously been experimenting with a lot of these deep learning chips at the edge for some time in the labs and so on, and we're excited about that. I mean, let's be honest. I mean, we were really excited with some of these early stage USB chip type deep learning frameworks that are coming out, which you can run on something really low form factor connected to a very low cost compute device. We see that having huge potential. I think what I will say is that we found that in practice, again, the cost becomes an issue. But also, I think, to your point, I think the use cases almost need to mature a little bit. I mean, where I see this really being extremely valuable is in these settings where you have that real-time control problem, things like robots and drones, and where you're dealing with those in remote environments, as I mentioned. And that means that you have to have this really reliable interface for those machine learning models. And you have to be really confident that when you deploy that container to the edge, that it's going to work. And as I said, I think, and one of your other guests mentioned it, that, I'm not, there are a lot of companies that are cracking this, and I know that, but I think a lot of it's being cracked in perhaps less challenging environments, where perhaps you have a bit more control, you've got a more reliable Wi-Fi network, you're not dealing with vast swathes of different facilities stretching over multiple miles, or similar with pipelines. And I think that's our challenge of we have these logistical challenges of managing it, and these are the sorts of issues that we have to correct for every day. And I think sometimes, to your point, this is all about business value. And when you're looking at cutting edge technology in a job like mine, you often have to say, is there a simpler way to crack this problem? Because whilst I'm a technologist at heart and I love this stuff and I think it's amazing and I'm excited about the potential of deep learning at the edge, I know it's going to be really important in cases like computer vision. I also recognize that we've got to get things out and deployed at scale. And sometimes there are simpler ways to do that, sacrificing a little bit of latency, for example.
True. All right. And I'm going to be opening it up for questions. So if you have questions, send them and tag Kevin. In the meantime, for what you're doing, and we talked about this a little bit on our prep call, but not that you need more data, but I'm really interested in some of the data that you're bringing in. This has less to do with machine learning at the edge and more on terms of training things and getting access to things at the edge. But can you talk just a little bit about the idea of simulated data in training using that?
Course.
Just because, again, I know it's more data, but I think it's a really interesting way to get info on the edge cases that we're trying to solve.
Well, and I think it's a really important point, right? So we talked about some of the data challenges, and even though we have a lot of data, the big problem that we have is that actually we often only have a very few examples of what we're looking for. So let me give some tangible examples for that. We deal a lot with things like corrosion. We deal with, for example, specific types of blockages in pipes. We deal with, for example, situations in which you may only have a very small number of this particular observation in the subsea where a particular type of event has occurred, like, a net getting caught over a pipeline, for example. And so these sorts of things, we don't have many examples, and therefore it's quite hard to train a machine learning computer vision algorithm to actually detect them consistently, because you just don't have enough. We had actually the same problem in retail, believe it or not, because you don't have a lot of examples of where people have been smoking, because you don't always catch them, they're not always looking, it's not the right angle, and so on. And so almost always the things we're interested in are the quote unquote edge cases rather than the general norm. So it's quite easy to detect edge from standard pattern, but it's quite hard to detect the specific thing that you want. And so one of the things that we've been working pretty hard on is how do you combine simulated synthetic data with the real data that you have in order to generalize that such that you can actually train effectively. And we think that's very important as part of the future. So using that quote unquote mixed reality setting where you take a realistic image and then you look at the potential variation within that image, you simulate that, and then you start to create a set of synthetic data that is very effective in detecting certain classes. That's something we've seen boost our results very significantly in terms of use cases like computer vision. And we're convinced that actually this is going to be the future in terms of making things work well, both in the cloud and at the edge for some of these complex use cases.
I have to admit, Dan, that I am still stunned that people are smoking at gas stations. I feel like did they not see Zoolander? I mean, pivotal scene.
It is amazing, It is amazing. It was quite funny. We put it out there, and I think people kind of sympathize with the problem because I think people related to it. So, yeah,
crazy. Okay, so some questions from the audience. Oh, this is a really easy one. Maybe I shouldn't say that. How small can the models get? What is the smallest model that you're running on the edge at Shell?
Good question. I guess in terms of how do you measure it, that's the question. I mean, I guess probably I couldn't give you the kilobytes, but it's pretty small. I mean, we're getting down to very small container type deployments for sure. Often, by the way, the reason they're quite small is because we're often doing initial filtering at the edge and then the verification in the cloud. So that's an interesting point as well, that often you are deploying small models to the edge, basically to reduce the data volumes, which is one of the cases that I alluded to earlier on. But you're talking, very, very, very small, kilobyte scale type model deploys. And I think the other thing is, we tend to try and think about what's the simplest model you can deploy to do the job. As I said, trying to reduce some of the complexity. Don't use a deep learning model when you can use something much more simple, for example.
Makes sense. Okay, let's see. Oh, it sounds like Shell is focused on getting data, centralizing the data, and then running the models against the data. Have there been any inroads in sending control signals back to the edge for process control changes?
That is a great question. So we would love to be there. And I think that is obviously the key towards automation. We have some really good examples where we're doing that. At the moment, though, and by the way, maybe I'll give one of the examples. So one of the things we're looking at is optimization for process control. So we are developing solutions where we have an advanced process control unit that's sending out signals. It's looking at all the parameters that are running, for example, in a liquefied natural gas train, and it's pushing those parameters back to a cloud-based environment, and then we're running optimization on top of that, and then sending advisory set points back down to the operators. Now, the key thing there is it's a really interesting one, because that's, and it goes back to the point I made earlier on around business process change. The question is, are you confident that the algorithm is able to perform in a way that you'll give it the trust to do it without the operator checking it? And I think, for us anyway, I would say probably technically we can. I think from an operational safety perspective, and also making sure that we understand these things as they're coming in, these types of fundamental changes, we are often having human in the loop. And I think it's an interesting point going forwards, because I do feel that the next generation of AI, as we move towards these highly complex systems, is actually going to require that human in the loop. Because I think you do want the verification often, particularly in industries like ours where safety is such a critical issue. But indeed, I think more and more there will be degrees of automation where things do happen directly, and where we're pushing, for example, set points directly back to those controllers.
And when you're talking about, because we're not all in the oil and gas business, I know, when you're talking about that example, what exactly are the set points that you're talking about? What are they monitoring on the liquid mesh? I mean, just to give a broad example.
Sure. So I mean, to give you an example, I mean, what you're often doing is you've got a whole series of different sensors through the piece of equipment that's effectively generating liquefied natural gas. What's happening is, in each of those sensors, you have a bunch of tends to be first principles based models that originally were developed in order to ensure that those things operate safely. And you have a series of set points, so upper and lower limits within which you want the entire process to operate. Now, the point is that obviously, as anyone knows, these processes vary quite a lot. And so set points vary too, as to what the optimal set point is. And we have the ability to change those set points dynamically. We've had that for a long time. And we're now using sophisticated optimization techniques on top of that, and the large data sets that I talked about, in order to better inform those set points in near time or real time.
Okay. Oh, here's a good question. Who is driving the push towards machine learning at the edge at Shell? Is it your CTO, CIO? What data sources are they using to justify their business cases? Oh, and this guy wants your ROI metrics. Oh.
No, I think, as I mentioned, right, we recognize that this is going to be very important. You can see, I mean, if you think about our industry, in an industry that's predominantly remote, has a lot of real-time processes that require real-time intervention, that also requires to be able to scale across all sorts of different devices that we have. It's very obvious this is going to be an important theme for us. At the moment, what we're doing is we're looking at it very much from a technology lens. So directly to the question, it's being driven basically through our research, our technology division, because we see the importance of it. As I said, we've had a number of successes. I talked about some. Maybe I'll talk about another one. So another example of where we're doing this at the moment is in the wells business. We have remote drilling rigs. And what we're trying to do is bring together machine vision technology with also real-time monitoring technology at the edge to provide much better insight around the optimum speed for the drilling process, for example. And we found that that's very effective. This is often a challenging process to do in the cloud, because it's very hard to get this data from a remote drilling site into the cloud. And therefore, doing this at the edge makes sense. And we've seen some very effective field trials at that. But again, it's at the minimum viable product stage where we're proving that it works. But I mean, to give you an example, you can see the business case for doing this, because you can remove a lot of the complexity in the processes. You can also do a lot of things in a more automated fashion. as I said, the inspection case is a great one for that. You can also have huge impacts on safety. So, and that's obviously a key driver for us. And often, for us, safety is so important that we do that almost despite the ROI. It's something that's just intrinsically vital to the way we run our business. It's something we care deeply about. And so I guess what I'm trying to say is that, at the moment, one of the challenges is getting to that ROI to really scale it. We see initial benefits cases for doing it, but I think we're going to have to see more of that before it really becomes ubiquitous within our organization.
And how does this conversation within the organization work? Obviously, you have your billions and trillions of data points, and you have your 3,000 data scientists, right? So
yeah.
They've got a sense of what's going on there. Then you have the people who have actual problems. How do they meet and communicate? Like, who says, "Hey, I think this data could mean something to you that could solve a problem"? How does that conversation happen?
So it's a really great question, and it brings me to the heart of kind of the change program that is Shell.ai. So we actually don't have about 3,000 data scientists. We call them citizen data scientists, and that's important. We have a core team of about probably about 200, 250 people who I would say are true data scientists. That's what they do. That's their job. And a lot of those are in my team, but there's other teams as well within the organization. And so what we try to do is we use those folks for some really high-end complex problems, typically coming out of research, things that are next generation problems in data science, machine vision. Some of the things, machine learning at the edge, for example, would fit into those sorts of categories. But the way we identify the business problems is actually that we encourage the people in the business, because as you already alluded to, we have a lot of technical staff, engineers, people with a big background in process control, people with experience in subsurface, electricity specialists, increasingly, folks that have a deep background in power. And so, we've got a lot of these types of roles within our organization. And what those folks are very adept. Most of them have a mathematical or a statistics background. Most of them are very comfortable with learning about new types of models, data-driven models. And so we've developed a program where we train those people up. It starts with kind of entry level. We have a network. That's where the 3,000 people come together. We put calls out there. We show them that's kind of level one. We also then have hackathon events with people where we try and share with them some of the tools that are available within the organization to help them solve some of their problems. We then also have training courses. So we've partnered with Udacity to develop something for citizen data scientists where they learn about machine learning, Python coding, and the like. And so we take these people on a journey where they start to understand what it means in terms of embedding AI in every part of our organization. And what we found is that what that does, it generates energy within the organization. It helps people identify where the value is, because the people who have the problem are able to understand this is a problem to which I could apply some of these AI techniques. And we also then build that connectivity between the professional data scientists and those people in the field for those complex problems. And actually, many of the cases where we've had the biggest success have emerged from people in the business with those problems. And actually that tends to be where it's most effective, because they want the change. They're pulling us in to help them to develop the solution rather than it being a technology push.
Okay. And that should be really heartening to everybody who has these problems and wants to develop this, because these are programs you can set out. Obviously,
absolutely,
you may not have the deep engineering, technical mindset that many Shell employees probably have, but there are going to be those people, and building these programs is important. Well,
no, I was going to say absolutely, and we've done this in HR. We've done this in marketing in terms of working with different departments of people without technical backgrounds, and even there, these tools are becoming easy enough that actually people can get their heads around them and start to do some pretty amazing things. So, I'm not saying they're ever going to develop a deep neural net which can be deployed to, an NVIDIA chip, but they can develop a simple workflow which has a, linear regression or the like in it.
Oh, even marketing people. Wow, those are people like me. All right, Dan, thanks so much for coming today. We appreciate it.
That's it for this week. Thanks so much for listening. And remember, if you'd like more IoT news, sign up for my newsletter at stacyoniot.com. We'll see you next week.